Hello, everyone, and thank you for attending today's webinar, Extend On-Premise Deployments to Azure HDInsight in Real Time. Before we begin, we wanted to cover a few housekeeping items. At the bottom of your audience console are multiple application widgets you can use. If you have any questions during the webcast, you can click on the Q&A widget at the bottom and submit your question. We will try to answer these during the webcast, but if a fuller answer is needed or we run out of time, it will be answered later via email. We do capture all questions. A copy of today's slide deck and additional materials are available in the resource list widget that looks like documents that are overlapping one another. If you have any technical difficulties, please click the Help widget. It is a gear icon and covers common technical issues. An on-demand version of the webcast will be available approximately 1 day after the webcast and can be accessed using the same audience link that was sent earlier. And now I would like to introduce our first presenter, Pranav Rastogi. Pranav is a program manager in Microsoft Azure. He focuses on Azure HDInsight, a managed cloud Apache Hadoop and Spark offering that gives you optimized open source analytical clusters for running open source projects. He spends most of his time making it easier for customers to leverage the ecosystem to complete big data solutions to meet their enterprise needs. I'd also like to introduce our second presenter, Paul Scott Murphy. I'd like to now, as VP of Product Management at WANdisco, Paul has overall responsibility for the definition and management of WANdisco's product strategy, the delivery of product to market, and its success. Now on to Pranav.
Thank you, Terry, and thank you everyone for joining us for this webinar. So I'll be talking to you about the value proposition that we have with Microsoft Azure and WANdisco, and how can sort of customers building big data applications can leverage this combined solution to easily extend their on-premise environments to the cloud. As you know, one of the key challenges that we have when we think about a hybrid is how do I ensure that I can have my data in sync in all the places that I'm experimenting with my data. And so WANdisco helps us sort of solve that scenario where it ensures that as data is replicated, data stays in sync across all the locations where you want to run your big data workloads. And Paul is going to talk to you more about the value adds of WANdisco. In general, what we are looking at from a Microsoft Azure perspective, right? Like in general, we are saying like cloud is inevitable. Like most of the customers, especially for big data, are now sort of moving to the cloud, and it's a common phase where they take a stepped approach. They'll build up a hybrid solution before they sort of figure out whether they want to migrate wholly to the cloud or they want to keep those hybrid systems running for a longer period of time. So it is for these situations where we need solutions like WANdisco so that they can help the customers to ensure that both their environments can run in real time. And the reason why most customers are moving to the cloud is simply because of the the scale and the economics in the cloud. It's very easy to procure hardware. It's on demand. You can use the hardware as much as you want, and once you are done with it, you can shut it down. So this is a fairly different more model of operation as compared to on-premises where you'll have your hardware running all the time. And also there are different kinds of use cases where customers can think about hybrid. It can range from I want to do backup and archival of my on-premise data to the cloud. I'm going to lift and shift my applications from on-prem to the cloud. I'm going to create dev test environments where I have most of my applications on-prem. I'll set up a hybrid environment in the cloud, start my dev test environment, and slowly migrate to the cloud. And then on the right side are how do you build end-facing customer applications around how do you build web apps, mobile apps, and the seamless app mobility. But across all these spectrum of use cases, you'll see a key consistent ask from customers is, I want this hybrid environment to be seamless. The data is available in both environments simultaneously. It's secure. How it's consistent, so I have the same tool sets that I could use on-prem to the cloud. If I'm using Spark on-prem, I can use Spark in the cloud as well. I'm using Hive or any of the open source analytical sort of projects that customers are experimenting with. And it's flexible because it allows you to start small and it allows you to go very big very quickly. And what Azure HDInsight is sort of bringing into this hybrid world is a fully managed big data service where as a customer you can spin up Hadoop, Spark, HBase, R Server, Storm clusters. And Microsoft provides you with an SLA of 99.9% on the availability of the entire cluster. It's not on the availability of the VM, but availability of the cluster. It's 100% open source. You can have clusters up and running in minutes. You can scale clusters on demand. And as you scale clusters on demand and create clusters on demand, there was a study done by IDC that your total cost of ownership gets reduced by about 60%. And it's fully secure. We also integrate with the sort of industry's leading ISVs, like WANdisco is one of them, where customers can sort of extend the capabilities of the Azure platform and complete their big data solution. And in this case, especially sort of build up their hybrid story. This is a sort of an overview of what does Azure HDInsight provide in terms of security and compliance. Again, so we have different levels of security. At the very extreme, we give you virtual networks and authentication using Kerberos or Active Directory, data security, which is around encryption, and then authorization, both at the workload level in terms of how our query is being run, and also at the data level on how the query is accessing the data. So you have full ACL all the way through from the cluster to the workload to the data stored in the cluster itself. And it meets a lot of compliance standards, which allows the customer to run this offering in sort of selected environments or store sort of PII data in the service. It's the most extensible platform, so you can sort of bring in a lot of open source projects and sort of third-party solutions. It's available worldwide, so this is just a snapshot of where Azure and HDInsight is available. It's also available in government clouds in China, Europe, and US, which allows customers to deploy their applications in these sovereign environments, which have sort of more regulations that a service has to meet. So this gives the customers a good option to sort of deploy and build applications on HDInsight while meeting the needs of the enterprise and the governments as well. What we've enabled with WANdisco is a single-click deployment. So you just go to the Azure HDInsight cluster, or you go to Azure VM and just install WANdisco with a single click, which will install the software, configure everything, and then you'll be good to go to sort of start using WANdisco to start setting up your hybrid environment. So with that being said, I would sort of pass it over to Paul to tell you about a little more on how you can use sort of WANdisco and be successful in your hybrid journey. Paul?
Yeah, thanks very much, Pranav. So this is Paul Scott Murphy from WANdisco. What I'm going to talk through in the remainder of the time we have for the webinar is just give a bit of a representation of our understanding of what the advantages of operating a hybrid cloud environment provide, some of the challenges that surround that in terms of the availability of data and regulatory compliance and general issues with hybrid operation that need some resolution. And then I'll introduce what it is that WANdisco and Microsoft Azure can do when they work together. I'll introduce the way in which the WANdisco Fusion product has been made available on the Azure and HDInsight marketplace. I'll show you an example of the technology in action to give you a demonstration of how a WANdisco Fusion can be used in conjunction with the Azure cloud and what that enables. We'll talk through a little bit of the detail about how the WANdisco technology works and what it allows you to do and some of the use cases for its application. So without further ado, I'll just move on to cover a little bit about that context. Pranav gave a very good introduction to the specific benefits of the Azure cloud, and in particular, its notion as being a cloud that is aimed at supporting hybrid operations with on-premises applications that you're familiar with, capable of working in a consistent manner with applications similarly deployed into the Azure cloud. A more general view of the importance of cloud obviously comes from the nature of how data are scaling and the reasons for why the cloud is driving the big data and analytics market. Obviously, at scale, the storage and processing and analysis of information is a significant challenge. Having the availability of cloud resources obviously improves the way in which organizations can accommodate and store and process data at scale. Around that, we see obviously emerging approaches to processing information in the fields of machine learning and AI that specialize techniques for using large volumes of data that are becoming more and more a key priority for many organizations. So what we see as an outcome of this is that although the knowledge of the growth of the big data and business analytics market is obviously going to be large in the future and is already very large today, it's the advantage that organizations can take from using cloud infrastructure in a more native manner that's going to allow them to take advantage of these opportunities. So behind that, of course, some of the major vendors providing public cloud solutions have emerged, and the Microsoft Azure cloud is a significant driver behind the core functionality to support the processing, storage, and analysis of information at scale to do exactly these sorts of things. Some of the unique elements of Azure that we've taken advantage of in building out this solution is the ability to build, deploy, manage, and automatically scale applications through a common and consistent administration environment. There's a rich range of services available in the Azure cloud, and Azure itself is targeted as being the very first consistent hybrid cloud with the facility to support applications that take advantage of both on-premises and cloud infrastructure. WANdisco's role in this is in the consistent and active replication of data at scale between these environments. So WANdisco's technology in combination with Azure cloud services makes that vision of a hybrid consistent cloud possible for big data solutions. And it requires the implementation of what we do for data replication to support consistency at scale in a manner that's flexible enough to work with the types of deployments that are typical for use in the Azure cloud. So I'm going to talk about three specific challenges that come from using cloud infrastructure and then talk to how WANdisco helps in solving these challenges. The three that I want to talk about are firstly the availability of data, ensuring that data can be made available in a consistent manner in both a hybrid and geographically dispersed cloud deployment. I'll talk a little bit about regulatory compliance for data availability, which is of increasing importance for global organizations that need to manage geographically separate uses of data. And then I'll talk to the specific challenges that come from operating data replication at scale in hybrid solutions, where it's the combination of cloud resources and on-premises infrastructure that need to be addressed. So firstly, in terms of data availability, when you think about cloud infrastructure, obviously the availability of cloud resources at scale is a significant improvement on the limited on-premises infrastructure that organizations typically have access to. But that by itself doesn't solve the challenge of ensuring that the data you want to make available in the cloud are available in whatever location that you need. The cloud by itself does not automatically distribute applications across geographically distant sites. It provides the infrastructure and the facilities to run applications in more than one location, but by itself doesn't provide the means to automatically distribute applications across those sites. Accommodating that means that you need to provide orchestration and management around application behavior yourself. In addition to that, the data that applications need to use must be made available across those locations as well. One of the ways of doing that in the cloud is making a single resource or a single source of data are shared across different applications or the same application in geographically dispersed sites. So that doesn't solve the challenges associated with speed of access to data, where you don't want to be encumbered by the network latencies in accessing data that may be geographically separate from where your applications reside. And it also doesn't solve the challenges of if you bring data local to where your applications run, the need to make the changes to those data consistent as applications work against local copies of the data. So data availability is a significant challenge in running a large-scale cloud deployment and certainly in operating a hybrid environment as well. The second challenge that I want to talk about in using cloud infrastructure is regulatory compliance. When you think about a solution where you've made data available across multiple geographies, your applications can work with it, they can modify that data, they can store and process it, they need to, with a great degree of efficiency because data are available locally for them. But just making data available is not sufficient for most applications that need to operate in a geographically dispersed manner. In many industries today, in many organizations, there's strict requirements around data availability, data masking, access to data from outside of a jurisdictional boundary that need to be addressed as well. Now, what this leads to is in deployments that span geographic sites, in addition to making data available, you need to have an understanding of the need for control around data availability and control around access to data and the ability to change it. So options that give you control over how data are coordinated and replicated in a selective manner with security constraints are going to become important if you need to operate under regulatory constraints for data access or control, or just have your own internal needs to manage access to data in geographically dispersed ways. So the cloud itself provides good tooling, and in conjunction with WANdisco's technology, the availability of data across geographically dispersed sites very well. But you also need to consider controlling the availability to data in a more stringent manner. So the third challenge I'll talk to is operating hybrid infrastructure. Cloud resources themselves, such as those available in Azure, represent a significant improvement in terms of flexibility and availability compared to standard on-premises deployments. But it doesn't solve the need itself of operating solutions where you take advantage of on-premises and cloud infrastructure. And that's what we refer to as a hybrid operating environment. In a hybrid environment, you're looking to address the type of needs where you are operating applications in an active manner in both on-premises and cloud infrastructure, but need to do that without downtime or disruption so that you don't introduce additional overheads that impose restrictions on how your business operations are performed. You may also be looking to operate a hybrid environment simply for the purpose of supporting disaster recovery needs, where it's the pure availability of applications and information that you're looking to use the combination of on-premises and cloud infrastructure for, to address business continuity and the continuous availability of data. So that's another example of hybrid operation. Another example of hybrid operation and the challenges that come out of that is in taking better advantage of both cloud and on-premise resources at all times. You can operate a hybrid infrastructure where you switch between these environments for simple disaster recovery purposes, but that doesn't take full advantage of each of the different types of infrastructure on a 24/7 basis. If you don't have the ability to make full use of all of your cloud and on-premises resources at all times, you will have infrastructure either sitting idle or incurring a cost overhead that is less efficient than you could achieve were you able to make better use of all of the resources on a continuous basis. So the other challenge around hybrid operation is in thinking about a true cloud or elastic data center enablement, where you are treating both data and applications in a more flexible manner, such that they can be deployed and used in either on-premises or cloud infrastructure at any point in time. So really the overall sense that I wanted to give you in talking about the challenges of operating hybrid cloud infrastructure is that they are significantly more challenging than a standard on-premises deployment or a cloud-only deployment. And the challenges there come from the need to both make applications and data available in a consistent manner across multiple types of deployment in a way that allows you to use that as infrastructure whether they're on premises or in the cloud at any point in time. So just talking about those three types of challenges, right? Data availability, regulatory compliance, and operating hybrid infrastructure should give you a sense for the sort of complexities that come from operating hybrid environments and using cloud infrastructure to its fullest potential. So I'll talk now about what it is that WANdisco is doing in conjunction with the Azure Marketplace to make this possible in an easier manner. To do that, I need to talk very briefly about the WANdisco Fusion product, because that's the technology that we are using in conjunction with the Azure and HDInsight Marketplace to make data availability, regulatory compliance, and hybrid operation much more easily obtained. WANdisco Fusion is a technology platform from WANdisco that enables the replication of continuously changing data between both cloud and on-premises data centers in a way that guarantees data consistency without introducing the need for any downtime or business disruption in application behavior. The way it does this is by implementing a distributed consensus protocol that guarantees the consistency of changes to data regardless of where those changes are made. We operate this technology in a way that allows it to span multiple types of underlying storage. That could be cloud object storage, big data environments like Hadoop, platforms like network file systems, physical transfer devices, and others. And what WANdisco Fusion does is it brings these environments together in a way that allows you to share data so that data are available locally to applications in the manner they're familiar with, allowing those applications to make changes to the data, but ensuring that their changes are consistent with all of the other environments that share access to the same underlying data. WANdisco Fusion is available today on the Azure and HDInsight marketplaces. You can access WANdisco Fusion directly from the Microsoft Azure Marketplace. Once you access it there, and I'll show an example of that shortly, you have the ability to replicate data between Azure data storage systems and other environments that WANdisco Fusion supports, which could be on premises, they could be in other Azure regions, they could be in other cloud environments as well. When you've made available the WANdisco Fusion technology in Microsoft Azure, you also have the option of integrating that in a very straightforward way with HDInsight clusters running in Azure as well. And that's very useful if you want to run a big data environment for the purpose of processing data at scale in Microsoft Azure using HDInsight's clusters. What we do there is we make available a component called the WANdisco Fusion HDInsight application that can be accessed from an HDInsight cluster once it's been launched in order to have direct and continuous replication for data shared with other WANdisco Fusion enabled environments. But just a quick quote here from the product marketing director at Microsoft AI, talking about the integration of WANdisco Fusion with Microsoft Azure HDInsight, enabling organizations to meet stringent data availability and compliance requirements. This is by way of reference to the fact that the combination of WANdisco Fusion with Microsoft Azure gives you the ability to have access to continuously changing data that span both Microsoft Azure and on-premise environments. And we'll show you an example of that through a demonstration shortly. When deployed, you can operate a hybrid cloud environment in a way that allows you to access the same data from multiple locations, whether they're on premises, across different geographically dispersed environments, or in the Microsoft Azure cloud. And this example here talks about the deployment model that enables the use of on-premises big data infrastructure in combination with an HDInsight deployment on the Azure cloud. Here, for example, we have a Fusion server instance, one of each in an on-premises environment and in the HDInsight's cloud. Those Fusion servers are responsible for communicating the changes to data that occur in either of those environments and guaranteeing the consistency of those changes as they occur. Once in place, the Fusion infrastructure ensures the consistency of those data. Applications themselves don't need to be concerned with the fact that the WANdisco Fusion technology has been introduced. They operate as they normally would in those big data environments without any change to application code. So introducing WANdisco Fusion makes a change in the way data are handled and replicated between environments. If you think about the difference between ensuring data are available without and with WANdisco Fusion, you get a sense for the way in which the technology WANdisco introduces enables this form of continuous replication with consistency. So if you are replicating data between on-premises and cloud environments without WANdisco Fusion, you're limited to doing so with data that are essentially static. You need to make a choice at a point in time of copying data from one environment to another. That means you immediately have a situation where the data that have been copied from one environment to the other are immediately out of date. Once it's taken place, you can't make changes to the data that have been copied because those changes themselves won't be replicated in like manner. So the data movement is essentially always behind the current state of applications accessing the data in their own environments. What that means is that there is no guarantee around the consistency of data if you don't have WANdisco Fusion in place. Now that may be a simple thing to overcome when you're dealing with small volumes of data. Copying data on a frequent basis as time progresses may be sufficient for you to accommodate your data replication needs. But when you're scaling that up to environments or to environments that accommodate very large volumes of data, which is typically the case for big data deployments, it becomes a significantly greater challenge. And resolving inconsistencies that are introduced simply because your data change on a frequent basis and do so at very large scale becomes a very difficult thing to accommodate. So introducing WANdisco Fusion is the solution to this problem. Without downtime to applications, WANdisco Fusion ensures that data are replicated between these environments continuously as soon as change occurs. What that allows you to do then is to support a variety of use cases that I'll talk to in a little while, including the migration of data between environments, but also hybrid operation, where applications can run in an active manner in any of these environments, sharing access to the same data. They could be at significant scale, perhaps hundreds of terabytes or petabyte scale, while WANdisco Fusion ensures that we guarantee the consistency of those data over time. It doesn't need to introduce downtime. You don't need to halt business operations. Fusion is the technology that ensures consistency of data. So it lets you replicate what we call active data between these environments. And active data means data that are changing. Replicating changing data is possible with WANdisco Fusion, where it simply isn't possible without that technology. So WANdisco Fusion itself is exposed in a very simple manner through a user interface that allows you to configure replication rules that govern the exchange of data between these environments. I'm going to switch over now to a short demonstration of how we can stand up and use WANdisco Fusion in combination with an on-premise and Microsoft Azure deployed environment to do exactly that. So this is an example of a Microsoft Azure environment where I've got deployed a WANdisco Fusion instance represented there as the WANdisco demo resource. Within my on-premises environment, I've got a small Hortonworks cluster running the Hortonworks distribution where I have a big data environment running. The WANdisco demo resources that are deployed in the Azure cloud consist of the WANdisco Fusion services along with a range of network configuration and storage accounts that are going to store the data that I'm replicating from my on-premise environment. In addition to that, for this demonstration, I have an Azure HDInsight cluster deployed, which references the same storage account that WANdisco Fusion is responsible for replicating with. So you see in my HDInsights cluster a range of head and worker nodes there. I've got 4 data nodes running, and those data nodes reference information that's stored in my Azure storage account. So I'll just go to that now and show you a quick representation of the storage account. You see there that WANdisco demo PSM storage account. And within that, we see the data structure of the information residing and that my HDInsight cluster has access to. We'll just drill into that there. And you should see the representation of the information that my HDInsights cluster has access to. So what I've done with WANdisco Fusion is configured replication for a specific location in that environment. Here on the left-hand side, you see the file system of my on-premises cluster, and on the right-hand side, the representation of the data available for my HDInsights cluster. They're different clusters. But I've configured this one location, /REPL, to have access to shared information. And we can see when I provide a listing of that, I've got a simple test file that exists in both of those environments, TTT. Within the WANdisco Fusion technology, I've configured a single replication rule for that /REPL location that replicates data between my Azure cloud and my on-premises deployment. So when I make an interaction with my on-premises cluster, here I have a 100 megabyte file that I'm just going to place into the /repl location. It's called big file, 100 megabytes, so it takes a little while to just load into my local cluster. Once that's been done, that same data will be available in the HDInsight environment. I can list the content in the REPL location in my on-premises cluster to show that the file is now available there. We'll see in addition to TTT, that big file. I can go back to the REPL location in my Azure storage and see it also represented there. So it's available immediately for my HDInsight cluster to have access to as well. When I list the content under the REPL location for my HDInsight cluster, the same data have been made available because WANdisco Fusion has provided the replication of that data in a live manner between those environments. So when WANdisco Fusion operates, it doesn't really matter where I make changes to that data. I could be doing that on premises. I could be doing it in the Azure cloud storage through HDInsight. As soon as the change occurs, for any replicated location where I have one of those rules established, the data are replicated and made available between those environments. The way WANdisco Fusion does this is it implements a consensus protocol to ensure that regardless of whether applications are operating in my on-premises or in the cloud environment, when change occurs, those changes are performed in a consistent manner across each of those deployments of the storage infrastructure. Now, WANdisco Fusion isn't limited to doing this just between two environments. I could stand up a complex scenario encompassing multiple deployments of different regions in the Azure cloud, of different clusters in a variety of on-premise environments. The simple demonstration that I've given here just shows you the very simple scenario of the replication of data in an active manner between an on-premises, a big data deployment, and the Azure cloud to make that data available for use by HDInsight. Equivalently, I could be doing that from a Hive table where I update Hive information and have a query that executes in either of those environments with consistent results returned from both my on-premises and HDInsight infrastructure. Now, the reason this is important, the consistency of those data, is because of the use cases that it supports, and I'll talk about some of those just briefly now. So WANdisco Fusion, in conjunction with Microsoft Azure and HDInsight, enables a variety of use cases that simply aren't possible without the type of active data replication that WANdisco Fusion enables. So the first that I'll talk about is data center to data center replication. So using WANdisco Fusion can be done independently of cloud resources. So if you have a geographically dispersed environment with either big data or other types of storage on premises that you need replication to occur between, WANdisco Fusion enables you to establish replication rules and replicate data between multiple deployments on premises as you see fit. Applications themselves, as I've said before, don't need to be concerned with how those data are replicated or making changes to how they interact with their underlying systems. WANdisco Fusion performs the replication in an active manner, irrespective of how applications running on big data infrastructure or cloud object storage need to access the underlying storage. But when we extend that out to the cloud, right, replicating between the data center and the cloud, you're talking about a truly hybrid environment now, and that's exactly the example I showed you a moment ago, where the replication of data between on-premises and cloud infrastructure enables use cases where applications operate in any of those environments as they normally would, which introduces the ability to perform migrations, to use cloud infrastructure for bursting your capacity from the on-premises environment, to make active use of each of those types of infrastructure on a continuous basis. It also supports scenarios where you are replicating between different cloud regions in an active manner. You may have applications deployed in different HDInsight clusters that have specialized operations for the application behavior that you need to accommodate, but that need to operate on the same underlying data. You can do that with WANdisco Fusion by replicating data between Azure regions or even between Azure and other cloud providers if that makes sense for you. If you're looking to migrate to the Microsoft Azure cloud platform from other cloud vendors, you can take advantage of WANdisco Fusion to accommodate exactly that, where you don't need to hold operations of the activities you're running in other cloud environments, but you can continue to operate those while using WANdisco Fusion to bring those data across to the Azure environment and make them available there. If your data are at significant scale, you might want to take advantage of technologies like Microsoft Databox to replicate data using physical transfer devices where the data scale is so significant that transferring them across the network is not a feasible approach to take. You might think that that limits the applicability of WANdisco Fusion, where WANdisco Fusion uses network resources to perform this coordination and consensus of change. But we're actually providing a solution in conjunction with Microsoft DataBox, where applications running on premises, for example, can continue to make modifications to their local storage while using a DataBox piece of infrastructure to transfer data in bulk to the Azure cloud while retaining consistency of change. So the WANdisco Fusion technology tracks the changes that occur even while a data box is in transit and loading data into the Azure cloud storage environment. And once those data are made available there, the WANdisco Fusion technology can continue to replicate in an active manner between the environments. So you can use this technology in a variety of ways, like replicating data between your own physical data centers, replicating data between your on-premises environment and the cloud, replicating between different Azure regions to make data consistent in a common manner regardless of where they're deployed, or even taking advantage of physical transfer devices like the Microsoft DataBox to do this at significant scale. So thanks very much for listening to the webinar presentation. I hope I've given you a good introduction to the types of challenges that can occur when operating hybrid environments, doing that across the Azure infrastructure in particular, and what it is that WANdisco Fusion is making available today in bringing this technology to the Azure marketplace and making it as simple as a single-click deployment to ensure you can replicate data in a consistent manner between on-premises and cloud environments to really take advantage of the Azure infrastructure. So I'll hand it back to Terry. I think we may have a few questions that have come through from the audience as we've been talking, and we'll attempt to address those now. Thanks, Terry.
Great. Thank you, Paul. The first online question is the network secure between on-prem and cloud?
That's a great question. When you think about connecting an on-premise environment to the cloud, what Azure provides you is capabilities where you can have a dedicated connection between on-prem to the cloud, and all the traffic that goes through the dedicated route is private. So it's called Express Route. It's a high bandwidth sort of data transfer, and so you can connect your on-prem environment to the cloud. And then in the cloud, you can sort of deploy your HDInsight clusters inside a virtual network. And then you can use the virtual network to lock down access to ports, IPs, or give access to certain ports and IPs that you want to sort of give access to. So you have full control on how sort of the data flows from your on-prem environment to the cloud.
Yeah, Paul here. I'll add a little additional response on that question as well. In addition to the mechanisms that Azure provides for ensuring the confidentiality of data that are transferred between environments as they are moved to the Azure cloud or replicated between continuously, using WANdisco Fusion provides additional controls over how data are encrypted while in transit, and also gives you the ability to control where data are replicated in a very straightforward way. The demonstration I showed established a single replication rule for a particular subset of data that required replication between these environments by making that data replication selective, and also by providing options for how data are encrypted in transit alongside the facilities that Azure itself offers for ensuring the confidentiality and integrity of data while being transferred. We have overall a very comprehensive solution for ensuring that data are going to be safe while being replicated between these environments. Thanks.
Great. The next question is, what open source workloads do you support on HDInsight?
So HDInsight, our key theme is that we are fully managed and we support a variety of open source workloads. So out of the box, you get optimized clusters which are fully managed, and you can create clusters for different kinds of scenarios. So we have Hadoop clusters where you can run Hive and do ETL. We have Spark clusters, which also give you notebooks experience as well. Then we have Kafka, which is used for streaming and ingestion. Then we have Storm for streaming analytics. You can also use Spark streaming as well. We have R server. So this is like open source R running at scale on HDInsight. We have HBase. We also introduced a new cluster type called interactive query, which is based on Hive LLAP, and it allows you to get sub-millisecond response time for querying over petabyte-size data. And beyond all of these supported workloads, we have a very rich extensibility model where you can easily bring in new open source projects that are coming in. So a classic example is, we are investing quite a lot in sort of data science, and so a lot of folks are going after it. The beauty of this combined solution and HDInsight, what it sort of relates to is you can set up your hybrid environment, sort of move all of your data or parts of the data from on-prem to the cloud, and then you can start experimenting with more and more of these open source projects. Like you can install H2O, you can install Cafe, and sort of go on that spectrum. And so now you can experiment with all these open source workloads and manage workloads in the cloud easier because you can now set up, create cluster, try it out. If that doesn't work, delete cluster and sort of try something else. So that rapid innovation that can happen once you set up a hybrid environment is very useful. Yeah, so we have set up fully managed open source workloads and then a rich extensibility system that you can bring any of your open source projects.
Great, thank you, Pranav. Okay, so the next question online is, what is the frequency or time of update on replication?
I'll take that one because I'm assuming it's in question on how WANdisco Fusion performs replication. The way we do replication with the Fusion technology is on a continuous basis. We introduce a mechanism to ensure that as soon as a change occurs in one of the environments, that change is performed in all of the environments at the same time. We perform that replication with strong consistency for any metadata changes to the underlying storage, which means that if I've created a file or deleted a file or renamed it, made some change to the file system itself, that change occurs as soon as it occurs in its source environment across all of the replicated systems. So if I'm creating a file in my on-premises system, I would immediately see the availability of that file in the Azure storage as well. The availability of data associated with those files is obviously dependent on the bandwidth between the environments, so that the content within files is replicated under the constraints of the bandwidth that the network between these systems can accommodate. So we perform strong consistency, immediate replication of any changes to the file system so that applications themselves can operate in that active-active manner where they all share access to the same representation of storage, and we maintain the semantics of single writer, multiple readers when a big data environment is using the underlying storage, so there's no change to how applications interact. So there's no real frequency of replication. Replication occurs continuously. As soon as change is introduced, WANdisco Fusion takes care of replicating that change for file system metadata with strong consistency and makes the file content available to applications elsewhere as the bandwidth allows.
Thank you, Paul. Another question on that, I believe. Is replication possible bidirectional?
Very simple answer is yes. The replication that WANdisco Fusion performs is a true peer-to-peer architecture where there is no single master, no single source of truth. All replicated environments share access to the same underlying representation of data and can make modifications to it at any point in time. So if I am introducing new data on premises, that data will be replicated to a cloud environment in a simple 2 environment scenario. Similarly, if I introduce new data or make changes in the cloud environment, those changes will be replicated in like manner back to the on-premises system. Also, I could have more than two systems involved, so it's multi-directional rather than just bi-directional. It's a true peer-to-peer active environment where change can occur in any of those locations, and we provide the consensus mechanism by which we guarantee the changes are consistent across all of those environments.
Great, thank you. Another question regarding WANdisco Fusion. Between cloud-to-cloud data transfer, what are the limiting factors that impact the performance? Is express route required or preferred?
The limiting factors I referred to before, obviously bandwidth is a limiting factor. There's no secret sauce to making it possible to send more information over the network than the bandwidth allows you to do. So express route is a good approach if you have a large volume of data that require replication on a continuous basis between these systems. It provides a means to ensure that the bandwidth available can accommodate the rate of change of data, and you need to ensure that whatever bandwidth you've allocated in replicating your environments is able to accommodate the change that occurs over time. The approaches that we take to support that are allowing the selective replication of data so that you choose which portions of content you want replicated between environments rather than replicating them all. We also provide selectivity of the participants for replication. So if you have an environment where there are multiple locations involved, you can be selective across which of those data will be replicated between so that you don't need to replicate it to all and have better control over your bandwidth use. But in the end, the limiting factors on the performance of replication are primarily the bandwidth between sites. The actual consistency and guarantees around how we ensure replication maintains a common representation of the underlying storage has no dependency on the bandwidth itself and no dependency on the latency between these systems. Regardless of the latency, WANdisco Fusion guarantees the consistency of change across those environments.
Okay, on to the next question. What specific technology does WANdisco use to capture continuous real-time inserts and updates to SQL Server database tables? Nearly all our source data originates there. Okay, so another question for us. The WANdisco Fusion technology is primarily aimed at supporting replication for file system resident data. So where a file is created or modified in one environment, we want to replicate that and make it consistent with other environments as well. We extend the technology in a variety of ways to accommodate other types of data storage, including cloud object storage technologies with blob storage in Azure, with things like Hive table replication and other big data environments. And we have a pluggable mechanism to allow us to extend the capabilities of the WANdisco Fusion platform over time. We haven't yet extended it to allow it to replicate changes to SQL Server database tables at any level other than how SQL Server stores data in the file system itself. So if your use case is to have active replication across applications sharing a SQL Server database between multiple environments, I don't know today that WANdisco Fusion is the appropriate technology for that. Great. On to the next question. What do you do with the old version of the files that have been changed? Do you keep past versions?
All right. The question here, I think, makes an assumption about how files are versioned and managed in a replicated environment. If you think about different approaches to replication, one of the ways in which you could achieve it is to support essentially a multi-version concurrency control scenario where applications in one of multiple replicated locations can modify their file system independently of one another, making changes to files that introduce a new version of that file in each of those environments. And then those new versions are shared over time between the environments so that there's some choice made on which version is used in any of the locations. WANdisco Fusion doesn't take that approach. What we do is we coordinate the intent of a change before the change itself occurs. Now, what that means is that if an application running in location 1 makes a modification to a file. That same modification is performed in location 2 and location 1 at the same time. It means that there isn't a notion of different versions of files that may be separate across each of the replicated locations. Rather, there is a single copy consistent view of the underlying file system, and there is no notion of file versions that are retained over time. Now, the one caveat to that is that if you have an interest in retaining copies of content that have been deleted for the purposes of ensuring that administrator error doesn't result in the loss of data, the WANdisco Fusion technology allows you to specify a strategy for retaining old versions of deleted content so that you can restore that at a later point in time. But for a regular active replication, what we aim to do, or what we do with the WANdisco Fusion technology, is provide a single copy consistent view of selected locations in shared storage across multiple environments, so that there's no notion of old versions of files that have been changed. We don't retain old versions of files. Rather, every environment has access to the same content, the same representation of the file system at any point in time.
Okay, and it looks like we have one more question. What is the hardware sizing for Fusion? T-shirt sizing?
Okay. Yeah, so I'm assuming that refers to kind of a small, medium, large type of deployment, and what do we consider small, medium, large, and what are the hardware requirements around that. We document this very effectively with the information that we provide alongside the product, but a typical deployment in a production scenario would need to account for not just the replication of data, but also the availability of the infrastructure itself. So we normally recommend that you run more than one instance of the WANdisco Fusion services in each of the deployed locations to account for high availability needs, so that if the Fusion service itself fails, or the hardware or virtual environment in which it's running doesn't operate correctly for some reason, that there is an additionally available runtime component that retains operations under those conditions. So you run at least 2 instances of the WANdisco Fusion services in each of the locations. And then in terms of the sizing for these things, we have standard production recommendations for a minimum of 16 gigabytes of RAM on each of the machines on which the Fusion services run for small deployments. Growing in size, it's typically the RAM requirements that grow as the volume of data changing increases, and that's how we would typically scale a solution, where we look at the rate of change of data occurring in the environments and scale out recommendations for the sizing of those as the environments grow. But the Fusion system itself is horizontally scalable. You can add instances of Fusion infrastructure over time to accommodate scale needs and build up the capacity in that way. But we also provide direct recommendations in the product documentation that refer to the specific sizing requirements that would be referring you to for the details. Thanks.
Thanks so much, Paul and Pranav. Thank you for joining today.